Hello, Richard Halverson here. This is ITS128, and we're starting a little late today because I recorded 5 minutes with the mute on, so I'm starting from the beginning. So today is March 4th, and we're doing the 10th video today, and it is we're going to finish up chapter 5. And so yesterday I covered the middle of chapter 5, and last week and the week before, I actually covered the first part of chapter 5, reinforced twice. But anyway, so let me share my screen. And so in the syllabus, we are here. I recorded video 9 yesterday, and video 8. This I actually did 2 video 8s. If some of you were on top of that, and I just saved the first one. And today we're going to finish up to section 5.13, and section 5.14 to 5.23. Those are labs, and they're at the end. Here's the textbook. This is where we're going to start today. And these labs at the end, they're a bunch of programs, and you have to get those running. And you should try to get them running on your own. But if you have any problem, if you just are stuck, then you can go back to you can go back to resources. Click on the resources folder, and then click on Fall 2020 videos. And you see that I cover the labs. I covered the labs last semester pretty well, so you can go back and refer to those. All right, so okay, so we're going to finish up chapter 5 today. So let's go there. This is where we ended up with yesterday's video, talking about nested loops, and we've just finished covering all about loops. And there's while loops and there's for loops, and the terminating condition, the way the loop is controlled with a for loop is quite a bit different than with a while loop. Anything you can do with a for loop, you can do with a while loop, but the reverse is a little bit more difficult. But with nested loops, that's where you have a loop inside of a loop, and we're going to see that when we cover sorting, because you need to do a loop within a loop when you sort. So we're going to get into that, and how you can figure out how long the program is going to take to run and so on. But today we're going to start with section 5.9, which is this incremental programming. And what that is we're talking about how to develop programs, and not programs that operate in a particular way. And with programming, because you can debug, you can start small and incrementally add functionality to your program until it evolves into how you want it. Because you can do that when you're developing a system, and you aren't breaking anything, and you aren't costing a lot of money, why not do it? And so then it becomes how good are you at taking a large problem and breaking it down into small enough problems that you can solve incrementally so your program works in the end how you want it to. And so this, as programs increase in complexity, the development process becomes more important. So here's an example. The following program allows a user to enter in a phone number like this, where you use the, you can make the last 4 digits be letters. And if you look on your keypad, you see next to each number, there's letters. And so, as a marketing tactic. And so this is a program that echoes the phone number. So you enter in a phone number like this, and it will output what the actual numbers are. See when it all works. Yeah, when it all works, you enter in the number like that, and it outputs exactly what the numbers are, where H is actually a 4, and O is actually a 6, and so on. And here you've tested it, so it works with lowercase letters, and then it still works with numbers, and it also is smart enough to know that that these characters don't correspond to numbers, and so it puts question marks there. And so this is where you want to be, and you're starting with a blank, a blank file, and you start typing in Python code, and you end up with something that does this. Well, that can seem daunting and overwhelming, but if you break it down, you break it down into bare bones, something that basically is starting to work, and then you keep on adding functionality. And so this is talking about that technique. And so the first version of your program may just echo the characters as they come in. So here, you ask the user to enter in a phone number. The user types that in. It's going to be stored in this user input, and then you're going to basically index through, the input, and you're going to want to recognize what each character is, at first. So, you're going to have a for loop, and it's going to increment character by character through the user input. And here we're printing it out that looks like that. Okay, so, and then the index, this one keeps count. It displays out as the element number. Okay, so once that works, then you can go in and you can modify what comes underneath the for loop. Okay, the incrementing character by character, because each character is going to be treated differently. At the end, we have each character, either translating or just being displayed out, or being recognized that it doesn't translate it into anything at all. So here we are going to see if the character is between 0 and 9, and if it is, we know that it's just a plain old character that's going to be, it's a valid key character for a phone number, and it's just going to be concatenated onto the end of the phone number. Otherwise, something, and we're just going to concatenate on a question mark. Okay, that's it. But we want to see that we got the numbers part right, and we're actually displaying out the whole phone number in a string, as opposed to down the line like we did up here. And we run this, and lo and behold, it looks like this. So it recognizes all the digits, and it puts question marks for anything else. You could actually run this. You should practice doing this. Let's see. I want to make sure I get through the whole chapter today. This 128. Okay, this was yesterday. I'm just going to get rid of this. And if we take this, I'll just be real quick here. Let's go through this. Let's copy this and paste it. And I'm going to save it. And I'm going to bring up a command prompt. Here it is. click. Yeah, I think I'm on my desktop. ITS128 and py test.py, and it asks me the phone number, and I'm going to type in this. I copy this and paste it, yeah, and it does exactly what we see here. And then we can put this down below. Well, it's actually everything below here. Copy. It's everything below here. Save that, and then run it again. And let's enter in the same phone number. And now it displays out. Ooh, gotta define phone number. This. Did put that in there. So I need to declare it. Equals nothing, right? Now, just as an aside, in most other languages, that would have passed, because the first time it uses the variable, it's more or less on it's on both the left side and the right side of the assignment statement, because this is phone number equals phone number plus character. And then the fact that you're appending a character would make it a string instead of addition. Although, since it's a number, it might no. Well, anyway, but in Python, it forces you to declare it first, as it should be, because if you don't, if this is the first encounter, then could be that really this was declared earlier, but it's spelled wrong, and the system thinks you're declaring a new variable when really you just spelled it wrong. And so with Python, it doesn't let that happen. So anyway, that was just an aside. And now this thing should behave like it does here. I might as well copy this. So now all we're doing is we're displaying it out this way. Same, no, it's not the same. It puts question marks if it's not digits. All right, so anyway, then this goes on and looks for characters, starting with ABC, because ABC is probably, if I don't have a keypad. Does it tell us what the keypad is? Oh, it's right here. Okay. Well, anyway, you can see A, B, C, D, E, F, G, H, I, or you can just look on your phone. Okay. So anyway, so you see how it's easy. It's easy to think of something that produces this, and then it's pretty easy to make it, instead of doing this to get to here. It's not that much more code. You're just going to process the digits and everything else. That's the easy part. Do the easy part first. And then you're going to have to do for every digit. Okay, so like this one, if it's this set of characters, then you append on a 2. You append on a 2. See if it's ABC or DEF. See, it's a 3. So you need to have a bunch of them all the way down. And in the end, you have a big long program. Oh, here we're actually wanting you to do the rest of them. So you do something like you would just do. This is for 3, for 4, for 5, for 6, for 7, for 8, for 9, for 0, I guess. And so here you would append on a 0, and here you would append on a 9. And here you would append on an 8, and so on. But then you have to change what these are, what these characters, what the characters are, the character spread. So it matches up what you see here, or it matches up what you see on your phone. Let's see, what is mine? Yeah, if you look, you know, on your phone. So anyway, that's how you would do that, and you can finish that. This tests your understanding of that. All right, so there's some other things that we have to make our loops, to add some functionality to our loops. Some things that are not necessary, but are convenient. They are a convenience, and basically they make it so so instead, you know, if you didn't have these things and you wanted to actually have it behave this way, it would probably cost another variable, and you'd probably have to keep track of something, and you'd probably, you know, the test would be more complicated, and it certainly wouldn't be as clear, because, you know, you would need to change something which causes you to exit the loop. In a okay, so this one is a break statement, and you can do break statements, I think, in all the loops. So something, you know, you're in a loop and you decide you're done looping, okay? And it's a for loop, for example. And so, you know, if it's a while loop, you just modify the condition somehow, but it's a for loop. And, you know, you want to really make it more efficient. And so you don't want to be looping through something after you've already found the answer, what you're looking for. So there's this break statement. And so if that's encountered, there's usually an if before it, because, you know, if a particular condition is true, then just break out of the loop. And so then it'll break out one level. So here we have two for loops. Okay, this is one for loop, and this is the body. This is the body of that for loop. And then we have another for loop here, and this is the body of that for loop. So this break statement breaks out of this body, and this break statement breaks out of this body. So in other words, this break statement breaks out of this for loop, and this break statement would break out of the outside for loop. Okay, so there's that. There's a continue statement, and what the continue does is that immediately jumps to where it's tested to see if the loop should loop again. So it skips everything below it. Okay, so the continue statement in a loop causes an immediate jump to the while or the loop header statement. The continue statement can improve the readability of a loop. So, so for example, if you reach, you know, let's say you're inside this loop, you know, yeah, you're inside the body. You're inside the body of this for loop, and you reach a point where you don't have to go through the rest of the range here, but you still need to stay in the loop. So this continue statement will skip this stuff here and go back up to the next. I said that wrong. This continue statement will go back up, we'll skip this and go back up to this heading again and go to the next one. You know, it's this thing increments through the range from 0 up to this value. And if it hits this continue statement, it's going to, you know, normally you'd have to go all the way down to here, and then it would come back up and go to the next number. But instead, this with the continue, it skips all this and goes back up there. Okay, that's how the continue works. So this is going to break out. So anyway, you can do these. What time is it? 10:57, and I'm here. Okay. So I'm going to try this just to make sure everything I said to you is right. Is this the right one to do? Yeah. Okay. So so this one here, the input is 8. Stop. So in range of 10, I see. So when result is greater than 8, we break out. We break out of the loop and we just print the result. Otherwise, if we don't break out of the loop, we print the end. Okay, so that's how that works. Okay, what's the first one? So I input an 8 and I go from 1 to 10, and the result is 8 times 2. No, where's and? Oh, 1 times 2. 1 times 2 is 2. Result equals 2. It's going to stop at 8. Okay, so 2 is printed because of this. And then it goes back around again, and this becomes n becomes 1. I'm sorry, it starts at 0. It starts at 0. And then it goes to 1 times 2 is 2. Oh, but we're adding it. We're adding 2 to result. So it's 2, print 2. And then we come back around and it's going to be 2 times 2 times 2 is 4. So 4 plus 2 is 6. I don't know if this is going to be right. And then it goes back around and it adds something. It adds so it's a 0, 1, 2. The next one is 3. 3 times 2 is 6. It adds 6 onto 6. It's 12. See, because then it breaks out and it prints the result, which is this. Oops, I'm supposed to be printing n instead. So I think this is 12, but I'm actually supposed to be printing n each time. So this is 1, this is 2. So each time I go through the loop, I print n, and then at the end, I print the result. So I think this is the right answer. Oh, I got to do this, I think. I don't know if this is the right answer. Oh. Is this the right answer? Yeah, I guess it is. All right, well, that's pretty clever. What's next? Continue. Okay, start out with result equals 0 for n in the range 0. So n is going to go, I'm going to bring up my whiteboard here. And I can close this over, and move this over. So for this one, n is going to go 0, 1, 2, 3, 4. And the first time, result is going to be for the first one, for 0, result is going to be n plus 4 is 0 plus 4 is 4. Result is going to be 4. And then result mod 2, yeah, mod 2. If result mod 2 is equal to 0, it will be equal to 0. Is not equal to 0, print that. Otherwise, oh, If it's not equal to 0, print continue. Print this and then continue, which means goes up to the range. Okay, all right, so every other time it's going to be, okay, so the first loop through, it's going to print the result. It's going to print 4. And then it's going to go back up, and at n equals 1, it's going to say result is going to be 1 plus 4 is 5. And result mod 2 is not equal to 0. So then it's going to print a dash. So at that time, it's going to print a dash. Okay, print. I'm going to say what's printed. This time, the 4 is printed. And this time, the dash is printed. And once the dash is printed, it goes back up. Once the dash is printed, it skips that. Okay, right, it should skip that. And goes to this one. And 2 plus 4 is 6, so the result is not, so it's going to print 6. And then it's going to print dash. And then it's going to print 8. And then it's going to print done. See if that's right. 4 space dash space 6 space dash space, oops, space 8 space done. I don't know if this is right. Let's see. Oh, it's right. Oh, that's good. All right, let's see. Well, you can, okay, so that had a continue, and then we saw a break. Okay, so anyway, so you can continue with this. It's not that hard. Simon says it's a memory game where Simon outputs a sequence of 10 characters, and the user must repeat the sequence. Create a for loop that compares each character of the 2 strings for each matching character at 1 point to the user's score. If there's a mismatch, you end the loop. So you're supposed to compare, I guess, loops, and so we want to index through the string. And so you can loop through, let's see, a 4. Okay, so you'd have a loop for the length of Simon pattern. And you want to test if Simon pattern, no, if Simon pattern, I don't know if this is going to work, equals, oh, how about not equals user pattern, it's not equal, then break. Oh, wait a minute. And then down here, I'm going to put user score, because if it gets to here, that means it got it correct. User score +1. Let's see if this works. I'm going to copy this, and I'm going to go to here, and I'm going to do paste, and I'm going to save this, and I'm going to run it. And the first thing it wants is Simon pattern, which is this. Copy, paste. That's Simon pattern, and then it wants user pattern. Can I just double click? Yeah. Paste. User score 4. So the first one matched, the second, the third, the fourth match, and then the fifth one doesn't match, you see. All right, so that's probably pretty close to the right answer. I'm gonna run and see. Good. All right. What else is there? Okay, there's this else clause that you can put on the end of loops. And a loop may optionally include an else clause, which executes only if the loop terminates normally by not using a break statement. So thus the complete forms of while and loops are, so for a while you can have, you have the while expression, and then this loop body executes as long as the while expression evaluates to true. And then if there's no breaks, and this thing finally evaluates to false, and that's the reason the loop ends, then the else will execute. It's possible that the loop ends not because the expression evaluated to false, but if instead a break was executed. Okay, if that happens, then the else clause will not execute. And for the for, same thing. If the for loop terminated normally, in other words, we got to the end of the iterable of the list or the range. If that happens, then after it's done with the loop, the else will execute. Otherwise, if the loop ends because of a break, then the else does not execute. So anyway, this shows that. Oh, here's a nice, clever program which checks if a user entered name is an appropriate Danish name. And apparently it says that some countries might have laws about what you can name your child for some reasons. Okay, anyway, so you can see this one. All right, so this shows, I guess you can be, it tests a closeness to the match of a valid to an acceptable name, and gives it a score, I guess. All right, or maybe suggestions. All right, so this tests your understanding of that program. Actually, this tests your understanding of this. Okay, let's see, X, Y, Z. We're supposed to say, what is the output of the code if Z equals 3? So if Z equals 3, it's going to be, okay, X increments X increments until if X equals Z, okay, X starts at 0, and if X gets to Z, it's going to break out. It's going to break out if X is less than Y. Yes, okay, so Y is 5. So this loop can go all the way up to where X is equal to 5. But because Z is equal to 3, then once X hits 3, it's going to break out then. What is the output? Oh, the output is X equals Z. And what is the output of Z equals 10? Well, if Z equals 10, the loop is going to stop because X is no longer less than 5. So if the loop stops normally, then this is what's printed. So this is what's printed. All right. So that's test your understanding. This also tests your understanding of when the else clause executes. That's pretty straightforward. All right. So here's a nice function where when you're looping, you can get both the index and the value. So let's say say you're looping through a list, or let's see, list. That's what they're called, array or list. And so this is the value of the first one is 4, and the value of the second one is 8, and the value of the third one is 10. The index of the first one is 0, the index of the second one is 1, the index of the third one is 2. So you see here, we are looping through the index and the value, and this is the index 0, 1, and 2, and the value is 4, 8, and 10, as we see here. And so if you wanted to print this out like that, you could either loop through the index, where the index goes through the range of the length of the list, and then you're able to get the value by referencing that indexed element of the list to get the value, and then you print it out. It's one way to do it. Another way to do it using a for loop is you loop through the origins list, one list element at a time, starting with the first element. So value is going to be equaling these values, not the index. But you can get the index back by using the index method of a list, and I wonder which one it gives you. So anyway, that's how you can get the index, and so that's another way you can do it. But if you have this enumerate function, you actually it is a method. It's a function that returns two values, the index and the actual value. It returns a pair. The first element is the index, and the second element is the value. So I'm curious about something here. I'm going to copy this here. Copy. And I'm going to go over here, and I'm going to select all, delete, and paste. And first, let me see that this works. Okay, that works. Now what happens if I go comma 8, comma 8, 8, 7, comma 8, comma 5. Okay, I want to see what the index of that is, the second 8. Okay, I'm testing this method here. Element 1, element 0, element 1, element 2, element 3. Where's element 4? So this will return the first index of that value. So this might not, so my point is that this might not work all the time. It only works if the elements are distinct. So instead you use this enumerate function. So I'm going to copy this and see what happens when I copy this. Copy, not this one. All right, let's see what happens now. Zero, 1, 2, 3, 1, 5. 0, 1, 2, 3, 4, 5. Ah, so the second one works as it should. The first one, this is the second one. The third one, the first one is wrong because it doesn't tell me the element number of the second one, of the second 8. So anyway, so that's how you use enumerate. And you can probably, you can test your understanding of enumerate. It's 11:19. Let's see. Print index and value to enumerate my list. So it's going to be 0, 1, 2, 0, 1, 2, Greek, Nordic, Mayan. Yeah, it's going to be this one. All right, let's try this. Using enumerate in for loops. Okay, 0, 1, 2, 3, 4. Yeah, 0, 1, 2, 3, 4. Okay, wait, let me ask. 1 black, no, 0 black, 0, oops, 0 black, 1 red, 2 green, 3 yellow. Enter. Black, red, green, yellow. 0, 1, 2, 3. Okay. Oh. These are reversed. So I should have put the color first and the index second. All right. Now what? Positions. Oh, now it's exactly right. Now it's the way. All right. 0, position 0, winter. 1, spring. 2, summer. 3, fall. Thanks. All right. So anyway, that's pretty easy. Oh, what is this now? Position number in enumerate numbers. If number is less than 0, then do that. Otherwise, do that. Okay, so number, that would be the second one. That'd be this. So for the first one and the fourth one, 0, 1, 2, 3. For this first one and the fourth one, it's going to print out the number. Otherwise, for the second, third, and fifth one, it's going to print out an X. So the position is always going to be 0. It's always going to be 0, 1, 2, 3, 4. It's always going to be that. But for the 0, it's going to be -6. And for 1, it's going to be X. And for 2, it's going to be X. For 3, it's going to be -9. And for 4, it's going to be X, methinks. Yes. Okay. All right, we're almost done here. How far? Oh yeah, okay, so this is the last one. And so I wasn't planning on going through this, but maybe I will, because I've got 7 minutes. And then for the rest of these, you can go back to the fall 2020 videos, and well, first try to do them, okay? And then if you can't, let's see what they look like. Convert to reverse binary. So here you're doing, you're looping while X is greater than 0, print X mod 2. It's going to be either a 0 or 1 that's printed. And then say X equals X divided by 2. That's an integer divide. And so the body of the loop is that. And X is going to eventually, you keep on dividing something by 0, or keep on dividing something by 2, and eventually you're going to get to 0. And then that's when it's going to stop. So anyway, you can go through these and try to do them yourself. And so let me go back to that dice one. Let me see if I can try to do that one now. The following is a simple programming lab activity. Not all cases using Zybooks require students to fully complete this activity. No auto checking is performed. Users planning to fully complete this program may consider first developing their code in a separate programming environment. Analyzing dice rolls is a common example in understanding probability and statistics. The following program calculates the number of times the sum of 2 dice randomly rolled will equal 6 or 7. I guess it's been so many years since I've actually been to Vegas, and I don't think I've ever done craps. But anyway, that must mean 7, I know, is something, or I guess, well, anyway, so we have a random number generator. Okay, so I'm gonna, well, let's see what happens when I just run this. We're supposed to calculate the number of times the sum of the randomly rolled dice equals 2 or 12. Okay, so create a different version of the program that calculates the number of times the sum of 2 randomly rolled dice equals 2 or 12. Okay, so this one, so we can just do num 2s equals 0 and num 12s equals 0. And if it equals 6, if it equals 7, oh, that's easy. So, you can do else if, or you can do else because, it's never going to be equal to more than one of these values, but I'm just going to do this. Row total equals 2, and row total equals 12. And this is num2s equals num2s. And this is num12s. Twos, 12s, twos, 12s. Now what happens when I run it? Yeah, okay. Wow, no 7s. All right, so anyway, and so you can continue with that if you want to fiddle with it. And so this concludes my chapter 5, and that's good because we are a little bit behind. But next week I may schedule 2 classes again and start chapter 6 functions, which is pretty important. So are there any questions?
I'm doing okay.
Okay, great.
Okay.
All right, thank you. See you next week.